Session authentication simply attempts to ensure that BGP routing messages sent between routers, between ASs, are authentic. Now, this turns out to be a little bit easier than it might appear because the session between these routers is a TCP session. Therefore, all we have to do is authenticate this session. The way that this is done in practice is done using TCP's MD5 authentication option. In such a setup, every message exchanged on the TCP connection not only contains the message, but also a hash of the message with a shared secret key. Now, this key distribution is manual. The operator in AS1 and the operator in AS2 must agree on what that key is, and typically they do that out of band, for example, by calling each other on the phone. But by calling each other on the phone and manually setting that key in the router configuration. But once that key is set, all messages between this pair of routers is authenticated. Another way to guarantee session authentication is to have AS1 transmit packets with a TTL of 255 and have the receiving AS drop any packet that has a TTL less than 254. Because most eBGP sessions are only a single hop and attackers are typically remote, it is not possible for the recipient AS to accept a packet from a remote attacker because likely that attacker's packets will have a TTL value of less than 254. This defense is aptly called the TTL hack defense for BGP session authentication.